Okay, it's 3 minutes past, so everyone else is considered late for class. Be marked accordingly. It's my pleasure now to introduce our first two panels to talk about digging into some of the more of the details of what we threw up there based on our research. To lead this first panel is Dr. Suzette Johnson, who is with Northrop Grumman, and she's a fellow working on lean, agile, digital issues. She's also the chair of NDIA's Systems Engineering Division and very active in what I told you about before, working with us and then me tricking her into doing work for me. As an example is what you see right here. So Suzette, thank you for moderating the session. Suzette, if you could you talk a little bit about the division before you start, and especially some of the work you're doing on digital engineering?
Yes. So first of all, good morning, and thank you for this opportunity, and thank you for being here today. I know everyone has busy schedules. So yes, I am the chair for the Systems Engineering Division for NDIA. Very excited about this opportunity, along with vice chairs Laura Hart from Lockheed Martin and Corey Acker from RTX. And it's a great, a lot of synergy that we have between us. And then we also have our committees, and the committees are so important within our divisions because they are the ones that are meeting like every week or every other week, working and discussing some of the challenges that we face from a systems engineering perspective. And we are also very closely aligned, if you are familiar with the DoD systems engineering modernization efforts and the MOSA and the modeling, along with the agile components and the digital thread through that. And as what we try to do, as a division and specifically within our committees, is really look at some of these challenges, and then how can we collaborate with our government stakeholders to talk about how do we overcome these challenges? What do you need from us? What do we need from you? And how can we shape it even better to even be more successful with these digital transformation journeys and the digital engineering efforts that we are trying very hard to integrate both within the industry and of course within the DoD and the services. And it's really a collaboration. I have been actually very active at conferences. Some of you may know that, along historically with Robin Yeaman from Lockheed. And why was that so important? It's because we learned within industry, no one company is going to solve this problem together, right? Or alone. We've got to solve it together. We have to work together across industry, across our FFRDCs and academia, and again, with our government stakeholders. So that is what we're working really hard to do within systems engineering, and not just within the systems engineering division, but how do we collaborate with our other divisions? Because our other divisions are also on the same journey from different perspectives, whether it's the robotics division or the procurement division or the manufacturing division. And there's 28 of them, so I'm not going to name them all. But again, right, we're all looking on how we can collaborate to do things better, to deliver value to the warfighter. And I always say, keep focused on the objective of what it is we're trying to achieve and how can we collaborate best to achieve that mission. So I could talk all day about that, but that's not what you're here for. We are going to move into our panel on overcoming pain points related to hardware prototyping. I'm just going to do a quick intro of our three panelists. After our three panelists have an opportunity to talk a little bit from their perspective, that'll help provide some context of where they're coming from. And then I'll open with a couple questions for them, and then we will open the floor. I'll be watching the Slido for your questions as well. And if you're not familiar with Slido, even if you're not entering a question, if you open up the app, you can actually vote and help prioritize questions. So So everybody can participate. And, half of you are probably looking at your phones anyway, so you might as well get on Slido. All right. So next to me is Miss Eileen Rubel. I am so excited. She and I have known each other for at least 10 years and have been on a very similar journey together. She is a technical director of Transforming Software Acquisition Practice and Policy Directorate at Carnegie Mellon's University Software Engineering Institute. Next to her, we have Chris Powell. And interestingly enough, I have also known Chris. We met actually in 2005, and I know that specifically because we were in our doctoral program together. So it's so nice to cross paths again with Dr. Powell. He is an MBA, and he is SAIC's lead for next generation computing and quantum science in the office of the CTO, and he is also a fellow. So very excited. And on the end there, we have Mr. Ben Harris, who I've just had the opportunity to meet. He's from the National Armaments Consortium. They selected Ben as their new executive director, effective this past December. And prior to that, he served as the chief of staff for the Joint Program Executive Office of Armaments and Ammunition. So very exciting. And we're going to start with Chris. Chris has a couple slides that he will share again to provide some context on the perspective that he's coming from. And then it'll go over to Ben and then to Eileen. And the thing is, you only get like 3 to 5 minutes. So, because we want to make sure we leave time for a good conversation with you.
You can throw your water bottle at me.
Okay.
Take too long. But I first decided I would try to talk about, since this is pain points, about some pain that existed in the acquisition system on different types of prototypes or different types of programs. And the first I thought was to kind of consider type 2 or false negative, where the prototype seemed like it was going to be a bad idea, but the program ended up being extremely successful. And then the other day, the idea of type 1 or false positives, where the prototype seemed like it was going to be a really interesting thing, and then the program crashed and burned for different reasons. And, those, if you think about it, during the journey of these programs, there was a lot of pain for the taxpayer, for the acquisition shop, for the engineering folks, for the customer, and for the operator. And, if you were the position of trying to say, sir or ma'am in the Pentagon, if you could just give me a few more $1 billion, I can fix this, you were also going to have a lot of pain in that briefing room in getting past this. And so part of the idea is what can a prototype do to both inform that process and help perhaps get past some of those issues. I was working in AT&L at the time, and then R&E, doing some statutory assessments of these. And I worked with most of these programs and was part of the pain in that process. And it was quite a journey during that. And what we typically found are, again, a lot of old saws in acquisition that were responsible for a number of these, especially including program scope, some excess ambition, perhaps requirements issues, which we've heard a lot about today, and also integration. In particular, integration was very hard. And for some of these systems like Future Combat System and Joint Strike Fighter, that was particularly, some challenging areas there. So that's the initial perspective I have for pain. The next slide I'll talk to in a little bit, but I'll let Ben go next with his information.
So this is an advertisement for the National Armaments Consortium. But what we do, the questions that were on the panel this morning were, I'm a small company. How do I get, and I've never worked with the Department of Defense, how do I get into this business? Well, that's our mission. That is what the NAC does. We foster collaboration events. Doug said it was $50 to join. It's $500 for our consortia. We're the oldest consortia. We were merged back in early 2000 with Warheads One out of Picatinny and a sponsor from the Secretary of Defense's office. So we've been doing this a long time. We host these collaboration events, and all our members can come. We have 1,100 companies right now in the United States. You have to be a U.S.-based company that are collaborating. And we bring them to these events, and we introduce the smalls, we introduce the non-traditionals to the bigs. The law, the 10 U.S.C. 4022, requires non-traditional participation unless the big wants to pay a third. Now, how many How many of you want to pay a third if you're a big? There's not a lot. It happens. It's recently happened. Okay, I have personal examples of that. How did I get here? So I was an armor officer, so I was the warfighter for a while, transitioned to acquisition when JSIDs came out, and I lived in that space for 5 years writing requirements. Prior to that, I was a contracting officer and doing prototyping. And then when I retired, I went into program management, doing nothing but ammunition, which is what the NAC is really all about, anything that touches ammunition. Aviation, we're doing future tactical UASs. We've done lasers. The first 300 kilowatt laser came out of the NAC as an OTA. The only thing we do is OTAs, and the only thing we do is prototyping. So I look forward to your questions, your pain questions.
So thanks to Suzette and Arun for having me, and thank all of you for now being my captive audience too. For those who aren't familiar with the Software Engineering Institute, I wanted to just lay the ground of why I'm here and where my perspective comes from. We're an FFRDC, but we are a very small R&D FFRDC operated at Carnegie Mellon. MIT's Lincoln Labs is the only real other analog. And in that capacity, so we were established to advance software engineering, cybersecurity, and now AI engineering for national defense priorities. We work with a lot of defense programs and organizations. And on my team specifically, my title is extremely long. But what my practice focuses on is integrating empirical analysis and data-driven insights and innovations in software engineering, research, and acquisition science to help reduce the complexity of acquisition and to speed up the adoption of software-related innovations in the department. And so we sit at this nexus of industry and academia and the DoD, and we get a little tiny bit of money. We get about $20 million a year, and that number hasn't grown in the last 20 years. We get about $20 million a year in direct 6.2 and 6.3 funding from R&E to advance applied research projects in software engineering that are tied to capability gaps in the department. And so we have researchers who are doing the work of advancing the science, and prototyping is a very big part of that. We also work with a lot of defense partners and industry partners to help sort of get over the hurdles and to help us get capability into the hands of the warfighter faster. And so I work with programs every day and I work with organizations every day, but we also have a research portfolio where I'm sitting here talking about how do we advance from prototyping and proving out concepts in the science that we're advancing. So.
All right, so thank you. So one of our first questions that we want to discuss is, what are the policy or cultural barriers that you've experienced or that you are thinking are currently hindering prototyping efforts?
I'll
So
take that
Ben?
one.
Okay.
So the DoD has a guide on other transaction authorities, and it says the intent is to adopt commercial standards and practices in our contracts. We currently have one vehicle, I won't say where, it has 21 DFAR clauses in it and 11 FAR clauses in it, but other transaction authorities aren't bound by the FAR. So I think and it depends on the services. We had an example. A requirement came out to defend all the forward operating bases in Afghanistan from rockets, artillery, and mortars. So from the requirement to posting it through the NAC and getting the first prototype successfully fielded, the CRAM system is what I'm talking about. From requirement to first prototype test was 1 year. It's now taking us 200 plus days from a requirement to get it on contract right now. So the policies that they've implemented due to their interpretation are all different. Some services, we still see 45, 50, 90 day from requirement to award. Other services, 300 days sometimes. So those individual policies that they've all glommed on as consortia have grown, we're doing about $2 billion a year, brought in a whole bunch of policies. And I think there's opportunities there to remove those policies.
Well, I think that there's also, I think Mr. Bush spoke about this earlier. We talk about saying, go take some risks in innovation. And that only works if we don't behead people when they come back and say, well, it didn't quite work out the way we intended, but we learned all of these other things too. And so there's still a lot of, I think, aligning the incentive structures, and I'm not just talking about like how we pay people, but right, aligning the ways that we give feedback and the tools and mechanisms that we provide to help acquirers, to help programs feel assured that when taking those risks and defining those prototyping activities effectively so that you know what you're going to get, you know what you're trying to answer. So they feel like the system has their back in taking the risk to get to the answers, even if the answer isn't, yes, aha, we can put that into production.
I think culturally, one of the important aspects, especially in DoD, quote unquote innovation, is that it's frequently based on fighting the last war. And moving ahead from that is sometimes difficult when you take a look at some of the current strategic challenges, which are upending both doctrine as well as warfighting systems. How do you proceed when you need new architecture, new doctrine, new everything? And you've touched a lot of third rails then culturally in a lot of the different parts, of the Pentagon and services. And it becomes too hard to think about just from a systematic perspective. And yet, you need to get past that because applying the techniques from the way of fighting the old war are not going to work anymore. They are going to take too long. They're going to, take too much in the way of, cross traffic and things like that. And we have to be able to speed that up. So getting past that, I think, is a significant challenge. But it's something that commercial industry has done fairly well. And, it's something, and also, by the way, R&D at universities or country consortiums and things like that. And it's important, I think, to take advantage of that. But addressing that cultural challenge, I think, is going to be quite significant.
Sort of facing risk by engaging in the patterns where you were successful before isn't necessarily what we need going forward and what we need to incentivize going forward.
Exactly.
Yeah, so building off of that, right? So we understand some of the cultural and policy barriers. Part of this discussion here, and then even a little bit earlier, was about fail fast, fail early, learn quickly, and the importance of learning. But pulling on that thread, how would you describe, or do you have an example of a successful failed prototype?
Yeah, when I was I was writing requirements, not JSID's requirements. This was in support of CENTCOM for urgent operational need statements for the Abrams tank. And tank commanders were getting sniped at. So we wanted to put a remote weapon station on the system. So we got prototype 1, and we borrowed a prototype from another system, integrated it onto the tank and tested it, and didn't like it. But we learned from that what kind of system we really needed. And then we found a system that couldn't quite meet the turret rotation speeds and stuff like that, but we were able to work with them to be able to accelerate that system, made their system better. And that's the system that's currently been modified many times now for the Abrams tank, and is still a potential thing they put on the tank.
One of my favorite failed prototypes was a circuit board we were making for a supercomputer back when we were first moving ahead to single gigahertz signals, nanosecond cycle times. The voltages, because of the transistor size at that time, were very significant. And so we accidentally had a little bit of a manufacturing glitch on one of the boards. And when we applied power to that board for the first time, it literally exploded. It was a very significant, rather interesting phenomenon in the lab. But we went back and went, all right, let's break out all the tools, all the ICE, all the oscilloscopes, all the multimeters and everything, find out, is there anything on this board we can use? And we found out we could, even though a lot of the signal paths had been compromised with the explosion. And we ended up succeeding with that system at the time. It was the fastest in the world. One thing I find neat about that system is, and I kind of, bring it to the present day as well, that it was a water-cooled or floor inert-cooled system. You had to accelerate coolant past the circuits at 60 miles per hour with no cavitation in order to have the heat density taken off of that thing. But the guideline for me is kind of, with the fun prototypes are the ones that are in bathyscaphe-like enclosures. If you don't have that, then it's just, there's not enough physics, to have fun with. But in any event, that was exciting work.
So I would pick a little bit of an argument with the question, but because I know you and I have talked about this before, which is the definition of what it means to have a failed prototype, to me, that means you haven't answered the questions you set out to answer at the beginning. And so maybe our goal is, maybe the goal was, let's see if this thing can take all this juice and operating in these environments. And if it explodes, well, okay, now we know the answer. I think a very big part of prototyping and understanding whether it's successful or not is prototyping is to buy down risk. It's to prove out some idea, whether it's feasible or executable or not within the context that you're operating in. And so, laying out very carefully up front, what is the information I need to understand at the end of this in order to make the decision that I am informing by the prototype. And so if you don't get to that information, if you get to the end of the experiment and you don't know enough to make the decision, that's where I think we've not achieved what we're trying to achieve with the prototype. So I answered your question with a completely
From a different perspective. Well,
yeah.
that's the beauty of a panel. We get different perspectives at looking at how we want to address and answer a question. So that's awesome.
I just want to add,
Yep, absolutely.
so, for ammunition, physics-based modeling is kind of challenging with explosives. So when the model says it's going to work and the prototype doesn't, then that feeds back to the modeling. So failed prototypes really are essential if we're going to ever digitize, ammunition prototyping. So we need failures to inform our models.
All right, so building off of that question, and I'm just going to take one. This one's from the audience, but it's very similar to a question that we discussed amongst ourselves. So I'm excited to see this. It says, what is the role of virtual prototyping in conjunction with or an advancement of hardware prototypes, and can a digital twin mitigate pain points? So I want to elaborate a little bit on that too, around digital twins. So if you want to answer with that, you might want to provide a definition, or at least your definition of digital twin. And then some of the conversations that I've had outside of this around this question also includes AI. So just to go back to the question, it has to do with the role of virtual prototyping, and can a digital twin mitigate pain points?
From my perspective, it kind of orients to what engineering is all about, which is, it's essentially, engineering has always been model-based. If you're doing CAD plots or VLSI drawings, you're working with models. It's just an idea of exactly how much you're capturing in the model and what you can do with it. Most of the modeling that we've done in engineering is what you might call descriptive modeling. I'm putting a drawing down, I've got metadata around it with specs and things like that. The opportunity with the digital twin now is to get much more into the prescriptive and behavioral modeling and the integrated aspect of that. So all of it is linked together, not just from an engineering or scientific standpoint, but also financial, manufacturing, logistics, operations, and things like that. And so the idea of having that digital twin, I think, is incredibly important, because the digital twin has engineering informing the field and the field informing engineering again from that perspective. I can exercise things before I have to spend money and break them. And so, I can exercise assumptions. I can also do trade space analysis of alternatives. I can reduce risk with a good digital twin perspective, and then highly target the real, T&E or V&V type work I want to do with that prototype in that kind of a scenario. And then understand also whether the real testing is informing the models and vice versa. Have I done the right thing in the right way?
So I took the class on digital twins just recently, but I wish we had had digital twins back when I was in Afghanistan in 2010. So the convoys were having all the problems with IEDs out there, and there was this Husky vehicle that had been developed in South Africa, and there was a company that had some MRI technology, and we wanted to integrate the Husky mine detector system. And as the Huskies are being built, we didn't have digital twins. So I'm in Afghanistan with field service reps getting Husky mine detector kits and trying to put them on Huskies, and the bolts aren't lining up and the holes aren't lining up. I think digital twins is the solution that we need to get there, because you can't modify a system in combat, because they're constantly changing as they're evolving to what the threat is. So I think it's a classic example, but.
And I think that anytime you can get more information, right? Everything you talked about was about adding to the information that you have before you need to bend something, whether it's bending metal or whether it's bending fiber optic cable or whether it's bending code. Um, the, I won't use the definition of digital twins, 'cause that's not my area of expertise, but virtual prototyping or digital modeling can help you do virtual integration of capabilities to, understand where you think you're going and even help you narrow down. We're working with a program where they want to get into a competitive prototyping situation. They're using some digital modeling up front of some key concerns to buy down some risk and understand basically what the parameters are around what they think what they're going to ask that competitive prototyping situation to do. But anytime you can get more information without bending code, bending metal, or entering into situations where you might have either loss of life or loss of material or whatever, it can only benefit. There's absolutely a role.
Right.
I'd like to add one more thing too, in that systems these days are far more complex than they used to be. Not just complicated. An automobile is complicated, has many thousands of moving parts. But the interstate highway system is a complex system, and we don't quite know exactly how it might work. No one person might appreciate it. With a large-scale system integration, you're going to be in a situation where you may not be able to know the implications of all the requirements or know all the corner cases of everything you're doing. So now, with a digital twin, I can be far more architecture-oriented, far more integrated in my thinking, have more of a systems thinking approach to not just exactly the system itself and what's happening with it, but how it's used, how it fits into its cultures of use and everything like that, and then continue to flesh out and exercise those assumptions as time goes on to make sure that I've got a good understanding of it, and then reduce at least the implications of complexity if I can't reduce the complexity itself.
Right. So do you think there are any challenges that we need to overcome with the adoption of digital twins, or do you think it's widely adopted already?
Well, one of the challenges that we saw was like who's writing the requirements and who's in charge of it. So standardization of it. It's similar with like a lot of our industrial base issues. Who's in charge of the requirements for it? If everyone is doing the duplication conversation they had this morning, is everyone doing it the same way, or is everyone kind of doing it a different way? And who's monitoring and controlling this? We're just scratching the surface up at Picatinny and ammunition, but it's like, okay, what's best to breed, or do we just do it on our own? Who's going to help us? I think that's an area of concern, especially with limited resources.
Yeah, I would say there's definitely a people, processes, and tools aspect to, digital twins. It's very much a data issue as well. When you try to integrate data across engineering models or financial models or things like that, you're in a hard place. And the typical ways that we have of making data more integrated by flattening it don't work. They don't preserve enough information or knowledge as you're trying to create that integration. So then what tools do you bring, or what processes do you have that then exercise that data and make sure that the assumptions you've written down, the requirements you think you understand, are written in the right language and are written in the right way that all the implications of them can be sorted out? I think today those data issues and those data integration issues have not been extremely well solved yet. They have in some ways, in some large-scale digital twins, like with CVN, also Common Basing Initiative, things like that. There was some really good, comprehensive recording of data in all of that, and those models were very good. I just don't think we have a general solution to that problem yet.
I'm just going to say what you said.
Yeah,
So.
yeah, that was great.
Add to that.
Beautiful. All right. So the question from the audience, and I see that some of you are starting to vote. Very good. We're starting to learn how to use that tool. Why can't the data collected in a prototyping activity be used by later stages in the acquisition process, such as testing or cost estimation?
Absolutely can, and it absolutely
It
should.
is, yeah.
Is this, we had a meeting yesterday with Chris Collins, who's leading DTE&A right now, about this very thing. And he said, Eileen, if you could work in the phrase test as a continuum, I'd be grateful.
Yes.
But we talked earlier today, and I think even I think even DAU's guidance on, right, the rapid prototyping activities talks about understanding the data you're collecting to make decisions so that you can use it for, we talked earlier about operators getting their hands on things. Well, that eventually turns into operational tests. We should absolutely be considering the evidence that we're collecting to answer our questions and how it can be used. Right? We don't want to throw it away. We want to treat the evidence like gold instead of exhaust. So yes, it absolutely should be. Sorry, that's my soapbox.
The one proviso I might add to that is that, and we heard this from the seminar before this, is, essentially the message is that the prototype is not the deliverable. So what is the data that you're getting from it? And you can certainly use the financial data, the engineering data, and things like that, but it is informing you about a prototype. It's not necessarily informing you about release 1 of the production model. And you have to be able to translate between those different atmospheres and not stress the information you're getting from the prototype into a place that doesn't belong. That may inform you to say, I need another prototype or a different one to exercise different parts of the model. But we just have to be careful with how much we use and how it's used.
So a lot of our data is still a DTIC technical report that came out, 20 years ago. And that's the challenge is a lot of it's in paper and in libraries and stuff like that and is not digitized. But the data is available and it is used. We can cut down the number of rounds we need to test if we can grab reports, which is data, and show the test community, hey, here's how this did with this specific explosive. Here's everything we know. So it's very similar. We're doing the exact same thing, only a completely different, form, fit, and function or whatever. But it's not digitized. It's in a lot of cases, it's still paper, TDPs and stuff like that.
Okay. All right, so our next question from our audience. Do you think there are opportunities to reduce the threshold to achieve DoD qualification, or is the current level of extensive testing the lowest it can go? It's a hard
I think it
question.
depends. I'm going to give you the classic DAU answer. It depends on what the system is.
That's the answer.
Great answer.
But it depends also what's happening, if you're on the live fire oversight, if they're watching what you're doing, years ago they were, they would want more rounds. But as you're testing, you might find out that things are changing. So yeah, that's all I got on that one.
I mean,
That's a tough one.
test events are served to collect data so that we can make a decision. And so I know we were both at the big the System and Mission Engineering Conference last fall, right? And the National Security Launch SPO came and said, hey, we're starting to talk about risk-based mission assurance, right? Where they're saying, okay, this is the context I'm in, and these are the kinds of data we have. And so based on the data that we've collected so far, maybe we can do that analysis without needing another test event because we've done a good job of lining up the context and explaining performance and everything else all along the way. And that's a big part of what DOT&E and DTE&A are working with the other agencies to try to get at is test is all about collecting data to understand, to make a decision. And if you you always need to make the evaluation to make the decision, but maybe you don't need another event to get the information that you need in order to do that. So it depends is absolutely, absolutely always the answer, but there's work we can do if we're sharing data and moving it in the right ways to reduce the collection events or the experimentation events if we're systematically building the bodies of evidence.
Yeah, and I'll build on that. It depends, of course, because, where is the prototype being delivered into? Is it being delivered into a risk reduction exercise pre-milestone A? Is it being delivered into an exercise, but an exercise where it's like, okay, everybody can come show us your cool stuff? Or is it more of an operationally flavored exercise where you actually need to get something done? Or are you actually farther along in the development process and expectations are increasing? One of the ways through all of that is to make sure that the types of metrics and performance indicators that you're looking at are well known. So you understand what success means in that kind of a setting, whatever the setting is. But knowing that, because you're part of a larger acquisition lifecycle, the expectations will be by the time you've reached T&E, DT or OT, that they will want to see those metrics in their standard form. And so even if you're delivering a prototype into a risk reduction, understanding a good idea of your KPIs and KSAs, or what your MOE, MOS, MOP are going to be for that type of operational setting, and being able to say, I can tell you about this, sir or ma'am, but I can't tell you about these things, but I know something here. You'll at least have that context set so you can make that part of it successful at that stage.
I'll just add on, our members would view testing as a good thing. It's not a bad thing. So, I mean, we want to get to the test, we want to pass the test, and then we want to be selected to go right into production, which you can do under other transaction authorities. So I'm a big fan of testing. I did that for 5 years. I mean, that's, and there is no standard. I think every service does it differently. That's why I said my answer is it depends. Every service, every single system, it depends. Is a soldier going to touch something and explodes? We better test that a lot. Okay.
What's our risk
But,
tolerance?
yeah, right. Is it airworthy? There's a lot more testing for airworthiness than there is for ground systems. So that makes sense, because when a ground system stops, it doesn't fall out of the sky and crash. It just stops, So again, I go back to it depends.
Right, so we've touched on this briefly when we were talking about successful failed prototypes and in the conversation right now, but to be a little bit more intentional and explicit, what do you think are actual measures of success or a successful prototype? And I'm curious, would government and industry view those measures as the same?
Well, a measure of success is, did we win a production contract? Period. That's what our members are interested in. But if they fail a test, then they go back and hopefully they learn and they put a little of their own IR&D into it and they figure out how they can compete next time.
I'll come at it starting a little bit from theory into practice and going back to the DoD prototyping guide. The idea of the models, you have different models: physical, digital, conceptual, and analytical. The metrics for those will vary. And the idea then is just to understand exactly what the goals for that are. What are the set of dependent and independent variables you're exercising with that model, whether it's on paper or virtually or in a lab. And then be able to understand how you're going to achieve them. How am I going to measure them? What will they mean in context? And are there other indicators of success, either lagging or leading, or failure for that matter, such that I can well exercise the model mentally as well as what I'm seeing in front of me? That's, I think, really what you're trying to get done with a prototype is you're in a problem space you probably don't know the final answer to, and it's going to take a few steps to get there, and you have to make sure that you're not overly prescribing or under prescribing, what you're trying to get out of that model.
I think it comes down to, I don't think you could ever get to, one ring to rule them all. Please tell me I got some nerds in here. All right. But what's the risk you're trying to buy down, and how are you going to know if you got there? And so what are the right measures are, do you have the information to make that decision? But also throwing in, and we can, I don't think we do this as well as we should consistently in the acquisition world yet. If your aim is you're really wanting to get at, is this something is it manufacturable, right? Is it physically possible to build the widget, and we're prototyping it this, that, and the other way? Part of what you're trying to understand with that prototype is not just, hey, can I make one? Can I machine one in this situation here? But do I have a viable strategy for scaling that prototype to production, whatever scaling it to production means? And we can construct the way that we use prototyping and acquisition to have that be part of the game, where you might have something that would be great, like, yes, we could go make a bunch of copies of it, but do the raw materials support it? Do we have the infrastructure? Do we, what's the I don't know, what's the capital outlay? How do we understand that? Are other things going to be ready? If it's our intent to say, okay, a success here would enable us to take this to production, part of the way we craft the prototype needs to be, can we answer the questions about what it would mean to scale to whatever production scale means for that thing, which is different for if we're sitting in Ukraine, wiring together legacy, doing experiments, legacy pieces and wiring things together versus, building something that we intend to deploy many of over many years.
And, the ultimate measure of success comes from the warfighters when they come home. They'll tell you, MRAP saved my life. The Navy right now is very proud. Their systems worked in the Red Sea, and they were able to shoot down everything that they needed to. The Sea Whizzes were working. Their missiles are working. They just need more missiles. So the systems are right. That's the ultimate measure of success, I think, for all of us are our warfighters surviving and coming home.
Another comment I'd like to add is regarding whether industry and the department sees it in the same way. And we learned in the previous session that was definitely not the case, right? DOD is thinking about learning things, and the industry is thinking about shipping things. And I come from industry, and I'm very comfortable with that. Especially when my leadership might say, "So you make money learning things?" From that perspective, at the end of the day, you better be somewhat focused on the final answer. And so again, getting back to the model and how you're putting it together, and the prototype goals and things like that, having that common understanding between the department and industry as to what exactly you're doing and why is very important. So both can be satisfied. I can inform the overall set of problems in the acquisition while I'm also informing my roadmap towards getting out the door with something that will work, and from that perspective.
And we need to be prepared for acquisitions to be flexible and malleable around the things around the things that we are trying to buy down with prototyping. We need to be able to come back and say, we learned these things. This is how we need to, that was our whole plan. So how do we need to adapt our strategies? What are the boundaries going to be on that next competitive prototyping contract? Or are there things in the environment now that we need to take into consideration when we're awarding the next contract? Or are there design things that we're ruling out? But we need to be able to take that input into how we design and execute acquisition programs too, in order to get to new capabilities, right? New capabilities in the hands of warfighters and everybody coming home.
All right, so the next question, there are 4 people wanting to know.
I know.
How important is prototyping for vendors to understand warfighter needs and DoD demand signal?
Okay, so under the consortium model, industry can bring their ideas to the government. So on 18 March, 19, 20 March, I'm advertising it, where I have a collaboration event. And we have speed dating at these events. So a small company who never had a government contract can show up and they can have a sit down with the project lead for a prototype. And we can collaborate with them and help craft what that requirement is in these conversations in the other transaction authority model. We do similar things in JSID. You'll go out and interview people, but we can do that speed dating thing in 3 days where the smalls can meet a bunch of bigs and figure that all out right there.
Yeah, I would say that prototyping is essentially the great crossroads of understanding between the vendor community and the warfighting community. If I have a good idea, but I don't know if it's relevant to the warfighter, I can use a prototype exercise in order to figure that out. Now, there's a great variable there in that the culture of how to do DoD acquisition is an extreme art and science, which if I have a good idea, but I don't really understand that atmosphere, I may have some serious trouble, right? But that's where mentor-protege relationships can also help, in that companies who really do know that very well can help that person say things in the right way, present things in the right way, and validate them in the right way, as well as then sponsor them into that acquisition model so it can work.
I got nothing else to add. That's
Okay.
fantastic. I want
right.
to learn more about your consortium. We'll talk later.
All right, so our next question from the audience. Are program managers incentivized to push their prototyping programs into further steps in the acquisition process? What are your thoughts on that?
Hmm.
I think program managers tend to feel a lot of pressure from that because you hear about things that failed or prototype that failed. And a lot of times we see people managing prototypes like they set it up like a whole program, right? Where they're not focused on the risk buy down. They're focused on the big the big programmatics instead of what do I really need to understand to buy down the risk, narrow the design choices, prove feasibility. We do see that.
Well, there's two types of program managers, or at least two. There's the contracting type, and then there's the government type. So as a former government type program manager, I did not see a lot of incentives because the federal government's, labor rates aren't really set up for that. There's all these rules. So, if you're talking financial incentives, no. I was on a team that did a top 10 invention prototyping, wanted an award for that. It was an enhanced 5.56 round. So we got an awards for that, which was a big deal. We made 5.56 more lethal than 7.62 through prototyping. But not, other than the medals, and the belaying, I don't see a lot of incentives. That was a conversation, though, that I had recently about even our contracting strategies. For the most part, a lot of our awards are cost plus fixed fee. They're not cost plus incentive fee. They're not cost plus award fee. But you can do that in the OTA model. The PM, though, has to set that requirement. We don't drive that train.
I think the topic of PM incentives is really excellent from within the government perspective in that, if you take a look at all the different requirements, all the different FAR and DFARs, if you take a look at the DAU curriculum, SPURDY, DWIA, all the different things you can do as a PM, you have an exhaustive amount of literature alone, let alone process and everything else that goes into that. And you can't possibly do it all. I'm not going to say some of the stuff conflicts, but it's at least hard to integrate sometimes. And so the right incentives, I mean, where is that PM? What does the PEO want? What does the combat leadership want? What does the user want? Really understanding exactly how to make that program succeed in the culture they're in is an incredible priority of a PM. And then being able to factor that back to the types of elements that make them successful, the contract structure, the technical requirements and things like that, and making sure that those things are rigorously, put together again within that context is one of the true skills and arts that PMs really have to be successful in that.
And I think,
Go
I'm
ahead.
sorry.
No, I was just going to say, I think that maybe one of the good things that we're talking about before is if you take risk and fail, are you going to get punished? And you don't want to get punished. So I think maybe one of the reasons, we don't have incentives that I saw for successful prototyping because we wanted to make sure they understood we're accepting the risk. If it fails, that's okay.
Mhm.
So, you're not going to get punished, but you're also not going to get a lot of incentives.
And I think very early on in the conversation, you talked about sort of a proliferation of guidance coming down that sort of removes the degrees of flexibility or perceived degrees of flexibility that program managers have. I think that's a big, talking about incentive, like crafting incentive fees around what you're trying to learn with prototypes, right? That's a fantastic approach, right? It's creative and you can really hit the button. I've been in rooms where I've said, hey, well, let's talk about, what if we talk about handling the money this way? And I got told, this service doesn't do that kind of contract. I said, okay, great. Give me a copy of that so I'm not telling people to do the wrong thing. They said, oh, well, we just don't. We just don't like to, because people tend to, there's this tendency, well, if you've got the whole universe in front of you to be flexible with, that's alarming. And so people with nothing but the best of intentions try to neck down the sources of risk for the people within their wingspan that they're protecting. And then we wind up overly protected. When really what we need is that cost plus incentive fee. And
Right.
All right. So our next question might need a little room for interpretation, but it says, is it easier to prototype for a commercial customer? If so, why do you think that is?
So I guess maybe the contrast there would be a commercial customer versus, say, a mission-oriented customer or something like that. And I would say the challenges are kind of completely different. And, you know, they have some commonality, you know, to them in terms of, again, I need to make sure my scope is correctly defined, the models are oriented correctly, you know, I'm working with the tools and things like that. But the incentives into each market are different. Each major sector are different, and the prototypes that are oriented to that kind of need to respect those differences. And I think sometimes it's going to be hard, especially if someone is working in both the commercial and the government side, to create a prototype environment that would function in both places well. We have found it at SAIC to be a challenge. We've found a way through that, but it requires a very comprehensive approach in order to make sure you're handling the imperatives and the expedience of both sides of the you know, of that atmosphere.
So I'm biased, I'll admit that. I think it's easier for the commercial sector to do prototyping, period. But, you know, it's hard for the government PMs to do it. A lot of the times, Stephanie talked about this, you know, they focus on technology readiness levels. And at times, what I've seen the government do is ignore supply chain readiness and manufacturing readiness. Now, we're trying to get there, but I've had many program reviews with prototyping coming out of our labs, and I've asked them, so are any of the raw ingredients from China? And they're like, I don't know. And I'm like, well, then I don't know why we're doing this, because if you can't tell me what the supply, well, the commercial sector is going to understand that, I think, a lot better. And we need to lean on that. And that's the intent of other transaction authorities. They're the experts in it. They have a vested interest in understanding their manufacturability and supply chain. I've taken prototypes from the lab, given them to industry and said, here's the prototype. Trust me, this works. And they will come back and say, your TDP is defective and it can't be produced. You can make it in the lab, but you can't make thousands of them. So I trust the commercial sector for that.
All right, so one more question and then we'll go into closing shortly. And it's twofold. What can government do to be a better partner to industry and prototyping activities? And what can industry do to be a better partner with government?
So I think the government is doing it. So I'll say it again. You know, the National Armaments Consortium is, I think, the oldest consortium, but the government sponsored it. The government asked for it, and as they saw the success coming out of the NAC, the DOTC which is one of our consortia, had everybody coming to it, and they learned. The services learned from that and created more consortia, and I think that's a true success story there.
I think that so much of this, right, is about like understanding what are we trying to buy down and where are we trying to go and what's the exciting thing. And I think that one thing that we can continue to do better on the government side, and I sit in this little space, right, academia, government, industry, like where everybody sort of meets. I think we've done so much in the last, you know, particularly in the last 5 to 6 years about trying to you know, improve the flexibility in the acquisition system and provide new and different kinds of authorities. And all of that flexibility is super, super, super awesome, but it can be intimidating to go out on your own, or to, you know, you have everything you can do, right? If I sent my kid to the bookstore and gave her $100, told her she'd buy anything in the bookstore, she came out with the $100 because it was just too, it was sort of too much. And I think that the more that we can do to provide tools or guidance or exemplars and success stories, not lessons written down, that, you know, we put on a shelf, but really being able to communicate about what this kind of, more examples of this kind of of the creativity and the kinds of flexibility that we have, I think is really important to making, on the government end, making us more sophisticated consumers who are able to consume prototyping in service to our missions in different ways.
Right.
So if that means there's $100 unspent that needs to get spent at a bookstore, I can solve that problem. I never have that problem.
All right, so we are in our last 3 minutes, so this will give you a minute each for your closing thought on if you oversaw all DoD prototyping and acquisition, what is one thing you would do to overcome the pain points in prototyping?
Are there any lawyers in the room? There is media, but I'm going to say it. I would do a riff of the lawyers. You'll have multiple agreements officers, and they all go through one lawyer. And so what you end up seeing is standardization. So I would riff the lawyers.
I suppose this is, yeah, my last message, but it basically, from an acquisition standpoint, it's about moving to rapid fielding, data-driven decision-making, particularly with respect to digital engineering and the digital twin-based environment. Built-in resilience is incredibly important. We tend to pursue that issue a little bit too fractally. Real focus on innovation and experimentation in everything, not just technically, but manufacturing, logistics, support, operations, things like that. All of those are prototype eligible. And then also agility. And not necessarily from the standpoint of failing fast. The idea is to understand something and move. And that it's the movement that's key. Your arc of justice should be towards success, not failure. But the point is that you're taking advantage of the information you've got and moving on it as fast as you can.
I want everyone to always be curious with the mission in mind. And I think if we are always curious about what the potential is to explore, or where there's new things that we can try that might be from unusual places or unusual technology. If we are always curious with the mission in mind, that's going to really unlock the power of prototyping for us at big scale.
That is great. So I'd like to thank our panelists for sharing their insights and their experiences with everyone today. And thank you for your questions. And hopefully, if you have time at the end and you want to ask some more questions, we might be around to address further conversation. So thank you so much and for this opportunity. Thank you.